Good morning, everyone. Am I audible? So, in this class, I would like to discuss about discrete Fourier transform. Right? See, we have already we know that Fourier transform or Fourier analysis is nothing but frequency domain analysis. By using this Fourier analysis, we can convert a time domain sequence to the corresponding frequency domain. But if you observe for Fourier analysis, means for Fourier transform, if we consider the discrete time Fourier transform, for every x of n, there exists an x of e power j omega, or it can also be written as x of omega, right? So if you consider here, even though x of n is a discrete time sequence, x of j omega or x of omega is a continuous time sequence, because if you observe the frequency, the phase and magnitude plots which we usually draw, this is how it looks, right? Means here omega is the continuous variable, whereas n is the discrete variable. So for transforming x of n into its frequency domain, we are converting a discrete time signal x of n into its continuous time equivalent in frequency domain, which is not needed actually, because we are here to process the signal on discrete digital signal process. For a digital signal process, the input should be digital input and the output is also a digital or discrete time output. So discrete Fourier transform is the discrete version of this discrete time Fourier transform. Discrete Fourier transform is nothing but discrete version of this discrete time Fourier transform. Okay, so let us see the how any signal exponent is transformed by using discrete Fourier transform. So if suppose x of n has the discrete Fourier transform of x of k, then x of k can be evaluated as sigma n is equal to 0 to k minus 1 x of n into e to the power of minus j 2 pi n k by capital N, where k is equal to 0, 1, so on n minus 1, right? Here it is a two-dimensional signal. Here it is a two-dimensional signal, because here there are two variables. One is n and the other one is k. So we can represent it in terms of a matrix. We can represent this equation in terms of a matrix. So once again I am writing, if x of n has the discrete Fourier transform of x of k, then x of k is evaluated as sigma n is equal to 0 to k minus 1 x of n into e to the power of minus j 2 pi n k by capital N, where k is equal to 0 to n minus 1. Similarly, if we want to find the inverse transform, means if we want to find x of n from x of k, so x of n is written as 1 by k, 1 by n sigma k is equal. See, this is n. So sigma k is equal to 0 to n minus 1 x of k into e to the power of j 2 pi n k by capital N, where n is equal to 0, 1, so on n minus 1. Okay. See, it is difficult to represent this equation every time. So what we are going to do is we are going to represent it in terms of we are going to simplify this one. So let e to the power of minus j 2 pi k by capital N is equal to omega power n. Omega suffix n. E to the power of minus j 2 pi k by capital N is equal to omega n. Right? Omega n, let us represent here. Right? So now let us try to simplify this equation. So sigma n is equal to 0 to n minus 1 x of n into omega n power nk. So this is what we usually call Twiddle factor. Where k is equal to 0, 1, so on, n minus 1. Whereas this can be written as 1 by n. Sigma k is equal to 0 to n minus 1 x of k into omega n power minus nk, where n is equal to 0, 1, so on, n minus 1. See, these are the formulas we should remember. These are the formulas we should remember. Okay? Is it clear? So, means మీరు సమ్స్ చేస్తూ ఉంటే డెఫినెట్గా ఈ ఫార్ములాస్ మీకు ఐ మీన్ you can remember these well. So let us do some sums. This is the generalized representation of discrete Fourier transform. You should remember these things. So find the discrete Fourier transform of x of n is equal to 1, 2, 3, 4 for n is equal to 4. Okay. In fact, అసలు ఈ discrete Fourier transform idea ఏంటంటేనమ్మా, మనకి యాక్చువల్లీ డిస్క్రీట్ టైం ఫోరియర్ ట్రాన్స్ఫార్మ్ లో మనం మాగ్నిట్యూడ్ ప్లాట్స్ అండ్ ఫ్రీక్వెన్సీ ప్లాట్స్ స్టార్ట్ చేస్తాం కదా, దాన్ని శాంపుల్ చేస్తాం. Suppose if this is the frequency magnitude plot, then this plot should be sampled at n regular intervals. This plot should be sampled at n regular intervals. So this capital N indicates the sampling number of samples in the fundamental frequency, number of samples in the fundamental frequency. So manaki ikkada we should find the discrete Fourier transform for capital N is equal to 4. Ikkada n ఎంత ఉందో x of n length kuda ala ante undali. So we should add one more zero at the end of x of n to make n length of x of n is equal to 4. So మనకి ఇక్కడ for n is equal to 4, n is equal to 5 అట్లా మెన్షన్ చేస్తే x of n should be of this length. If not, we should add zeros at the end of x of n to make its length equal to specified length, right? So as we have discussed previously, if x of n has the DFT of x of k, then x of k can be written as sigma n is equal to 0 to n minus 1 x of n into omega n power nk, where k is equal to 0 to n minus 1, right? So sigma n is equal to 0 to 4 minus 1 means 3 x of n into omega 4 power nk, where k is equal to 0, 1, 2 and 3, right? So let us expand this equation initially. So x of k can be written as, let me expand this summation. If we substitute n is equal to 0, x of 0 omega 4 power 0 plus x of 1 into omega 4 power 1. See, నేను ఇక్కడ సమ్మేషన్ ఎక్స్పాండ్ చేస్తున్నాను. ఫస్ట్ n is equal to 0, 1, 2, 3 సబ్స్టిట్యూట్ చేస్తున్నాను. ప్లస్ x of 2 into omega 4 power 2 plus x of 3 into omega 4 power 3, right? And this is the valid equation for k equal to 0, 1, 2, 3. Let me substitute these values here. X of 0 is equal to x of 0 into omega 4 power 0 plus x of 1 into omega 4 power 1k, isn't it? It is 2k. It is 3k. So since we need here x of 0 into omega power, since in this equation we are substituting k equal to 0, so omega 4 power 0 plus x of 2 into omega 4 power 0 plus x of 3 into omega 4 power. So x of 3 into omega 4 power 0. Okay, let me now substitute k equal to 1. So if we substitute k equal to 1, x of 1 is equal to x of 0 into omega 4 power 0 plus x of 1 into omega 4 power k is equal to 1 plus x of 2 into omega 4 power 2 plus x of 3 into omega 4 power 3. Let me substitute k is equal to 2 here. X of 2 is equal to x of 0 into omega 4 power 0 plus x of 1 into omega 4 power k equal to 2. 2 ones are 2 plus x of 2 into omega 4 power 4 plus x of 3 into omega 4 power 6. Let me substitute k is equal to 3. X of 3 is equal to x of 0 into omega 4 power 0 plus x of 1 into omega 4 power 3 plus x of 2 into omega 4 power 6 plus x of 3 into omega 4 power 9, right? So since this equation is varying in terms of both n and k, we can represent it in terms of a matrix. If you observe, so x of k is equal to, see, let us write the twiddle factors of first equation initially. See, this omega n power nk is called as twiddle factor. So omega 4 power 0, omega 4 power 0, omega 4 power 0 and omega 4 power 0. These are the twiddle factors of first equation. Next, let us write down the twiddle factors of second equation. Omega 4 power 0, omega 4 power 1, omega 4 power 2 and omega 4 power 3. Let me write the twiddle factors of third equation. Omega 4 power 0, omega 4 power 2, omega 4 power 4, omega 4 power 6, and then for fourth equation, omega 4 power 0, omega 4 power 3, omega 4 power into x of 0, x of 1, x of 2 and x of 3. Is it clear? So మీరు అబ్జర్వ్ చేస్తే ఈ వితౌట్ రైటింగ్ ఆల్ దీస్ ఈక్వేషన్స్ ఆల్సో వీ కెన్ రైట్ దిస్ మ్యాట్రిక్స్, రైట్? సో మనం ఇక్కడ ఉంది 4/4 కదండి. దిస్ ఇస్ a 4/4 matrix kada. Here if you observe, let us take the numbers here from 0, 1, 2, 3. Let us take the numbers here from 0, 1, 2, 3. Twiddle factors etla raichu ante 0 into 0 is equal to 0. Omega 4 anedi common, since we are finding here for capital N is equal to 4. N is denominator anedi 4 definitely ga untundi. Whenever we want to write the new the prefix the power here, then let's just multiply these two values, row factor into column factor. 0 into 0, 0, 0 into 1, 0, 0 into 2, 0, 0 into 3, 0, 1 into 0, 0, 1 into 1, 1, 1 into 2, 1 into 3, 3, 2 into 0, 0, 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, 3 into 0, 0, 3 into 1, 3, 3 into 2, 6, 3 into 3, 9. This is how we can write a matrix. సో నేను ఇది మీకు ఫస్ట్ ఎక్స్ప్లెయిన్ చేయడం కాబట్టి ఇదంతా చేస్తున్నానండి. మామూలుగా మన ఎగ్జామ్లో చేసేటప్పుడు ఈ ఒక ఈక్వేషన్ రాయాలి, దిస్ ఈక్వేషన్ వీ హ్యావ్ టు రైట్, దిస్ ఈక్వేషన్ వీ హ్యావ్ టు రైట్, అండ్ we can directly write this matrix. We need not to go for all this expansion. ఇది మీకు నేను ఈ matrix ఎట్లా వస్తుందో అర్థం కావడానికి చెప్పాను అంతే. That's it. Okay. So here our x of k is equal to omega 4 power 0, omega 4 power 0, omega 4 power 0, and omega 4 power 0, omega 4 power 0, omega 4 power 0, and omega 4 power 0, omega 4 power 1, omega 4 power 2, omega 4 power 3. Omega 4 power 0. So now we want to find this Twiddle factor values. Okay, let us first write all these Twiddle factor values here. Omega 4 power 0, omega 4 power 1, omega 4 power 0. E row and the column completely omega 4 power 0, and then omega 4 power 1, omega 4 power 2, omega 4 power 3, omega 4 power 4. What more? Omega 4 power 6 and omega 4 power 9, right? This omega 4 power 0 means e to the power of minus j 2 pi into 0 divided by 4, which is equal to e to the power of minus j 0, which can be written as 1. Omega 4 power 1 is e to the power of minus j 2 pi into 1 divided by 4, which is equal to e to the power of minus j pi by 2, which can be written as cos pi by 2 minus j sin pi by 2. See what is cos pi by 2 value? 0. Minus j sin pi by 2 value is 1. So minus j, that is equal to minus j. What is omega 4 power 2? E to the power of minus j 2 pi into 2 divided by 4. E to the power of minus j pi, which can be written as cos pi minus j sin pi. What is the value of cos pi? Anyone in the class?
-1, madam.
Cos pi is equal to -1. Sin pi is equal to 0. Right? So omega 4 power 3 e to the power of minus j 2 pi into 3 divided by 4, which is equal to e to the power of minus j 3 pi by 2, which can be written as cos 3 pi by 2 minus j sin 3 pi by 2. Cos 3 pi by 2 is equal to 0 and sin 3 pi by 2 is equal to minus 1. So this value is equal to j. E to the power of minus j 2 pi into 4 by 4. E to the power of minus j 2 pi, which is equal to cos 2 pi minus j sin 2 pi, which is equal to 1. Omega 4 power 6 e to the power of minus j 2 pi into 6 by 4, which can be written as e to the power of minus j e to the power of minus j 3 pi, which is equal to cos 3 pi minus j sin 3 pi whose value is equal to minus 1. E to the power of minus j 2 pi into 9 divided by 4, which can be written as e to the power of minus j 9 pi by 2, which is equal to cos 9 pi by 2 minus j sin 9 pi by 2, which is cos 9 pi by 2 is equal to 0 and minus 9 sin 9 pi by 2 is equal to 1. So this should be equal to minus j. So if you observe here that మనం అన్ని twiddle factors find out చేయట్లేదమ్మా. If you observe the logic, here this twiddle factors are following symmetry and periodicity property. Means we can write omega 4 power 4. If you observe omega 4 power 4 and omega 4 power 0 values are equal. So that we can directly write omega 4 power 4 here. మనం ఇక్కడ వరకు find out చేస్తే సరిపోతుందన్నమాట twiddle factors. Remaining twiddle factors అన్ని మనం periodicity property ని యూజ్ చేసి చేయొచ్చు. The periodicity property that follows here is omega n power omega n power n is equal to omega n power n plus n. అంటే suppose omega 4 power 6 ఉందనుకోండి, this should be equal to omega 4 power 4 plus 2, that is equal to omega 4 power 2. That is how. So so let us try to apply the periodicity here. So here this can be written as omega 4 power 4 can be written as omega 4 power 4 plus 0, which is equal to omega 4 power 0. And as we have already known, omega 4 power 6 can be written as omega 4 power 4 plus 2, which is equal to omega 4 power 2. And similarly, omega 4 power 9 is equal to omega 4 power 4 plus 5, which is equal to omega 4 power 5. Still this can be written as omega 4 power 4 plus 1, that is equal to omega 4 power 1. This is equal to omega 4 power 9, right? So the equations now can be simplified as that is equal to 1 1 1 1 1 1 1, because omega 4 power 0, this column and this row both are omega 4 power 0, right? So 1 1 1 1 1 1 1 1. Next one is omega 4 power 1, whose value is minus j, and the next one is omega 4 power 2, whose value is minus 1. and the next one is omega 4 power 3 whose value is j, and the third column is omega 4 power 2 whose value is minus 1, and the next one is omega 4 power 4 whose value is 1, and the next one is omega 4 power 6 whose value is equal to minus 1. And here it is j omega 4 power 6 whose value is minus 1 minus j into, here this is 1 2 3 0. Let us multiply these things. 1 plus 2 plus 3 plus 0. 1 minus 2j minus 3 plus 0. 1 minus 2 plus 3 minus 0. 1 plus 2j minus 3 plus 0. 6 minus 2 minus 2j minus 4 minus 2 is equal to 2, and here it is minus 2 plus 2j. Okay, is it clear? ఒకసారి మళ్ళా చెప్తున్నాను. అంటే మీకు కొంచెం ప్రాసెస్ అర్థమైతే విల్ వాంట్ టు నెక్స్ట్ సమ్. మనం నెంబర్ ఆఫ్ సమ్స్ చేసే కొద్ది యూ మే గెట్ హ్యాబిచుయేటెడ్ టు దిస్ ప్రాసెస్. అండ్ మనం అది ఇంత క్లమ్సీగా సమ్ చేయగలేదండి. మీకు అర్థం కావడానికి నేను ఫస్ట్ సమ్ కొంచెం ఎలాబరేటెడ్ గా చెప్పాను. ఇస్ ఇట్ క్లియర్ ఎవ్రీవన్? ఫస్ట్ అండ్ ఫార్మోస్ట్ థింగ్ ఇక్కడ మనకి ఏంటంటే క్యాపిటల్ N x of n length should be equal to capital N. If not, we should make the length of x of n equal to capital N. And then మనం x of n కి expansion రాయాలి. x of k is equal to sigma n is equal to 0 to n minus 1 x of n into omega n power n k. k is equal to yeah, tell me everyone. Okay, it's fine. Where k is equal to 0 to n minus 1. Let us substitute capital N value here. Then it should be sigma n is equal to 0 to 3 x of n into omega 4 power n k, k equal to 0 to 3. And this is how we usually expand. First in terms of x of n expand చేస్తాం, ఆ తర్వాత k is equal to 0 1 2 3 substitute చేస్తాము. Examination point of view లో అయితే you can directly write this twiddle factor matrix. This how in background ఏంటంటే just every equation twiddle factors let us write in row wise and let us multiply these two in order to have the finalized twiddle factor matrix. Okay. అండ్ మనం వీటిలో ఇప్పుడు ఎక్స్ 4 కదండి క్యాపిటల్ N, మనం సో ఒమేగా 4 పవర్ 0 టు ఒమేగా 4 పవర్ 3 వరకు ఫైండ్ అవుట్ చేస్తే సరిపోతుంది ట్విడిల్ ఫ్యాక్టర్స్. రిమైనింగ్ అన్ని పీరియాడిసిటీ ప్రాపర్టీని యూజ్ చేసి ఈక్వేట్ చేసుకోవచ్చు. ఓకే, లెట్ us do one more sum. Capital N is equal to 4, right? So ఇక్కడ మనకి x of n is also of length 4 and capital N is equal to 4. So we need not to worry about the length. Okay. So if suppose if x of n has the DFT of x of k, then x of k can be expanded as sigma n is equal to 0 to n minus 1 x of n into omega n power nk, where k is equal to 0 to n minus 1. Here capital N is equal to 4. So let us substitute this value. N is equal to 0 to 3 x of n into omega 4 power nk, k is equal to 0, 1, 2, 3. Let us represent these equations in terms of Twiddle factor matrix. So x of k is equal to మా ఎవరైనా ఈ ట్విడిల్ ఫ్యాక్టర్ మ్యాట్రిక్స్ చెప్పడానికి ట్రై చేస్తారా? Anyone in the class? So, anyone in the class, can you tell me the Twiddle factor values? Omega 4 power, what is the index here? 0 into 0, 0.
0, ma'am.
0 into 1, 0. 0 into 2, 0. 0 into 3, 0. Coming to here, 1 into 0, 0. 1 into 1, 1. 1 into 1 into 3, 3. 2 into 0, 0. 2 into 1, 2. 2 into 2, sorry, 2 into 1, 2. 2 into 2, 4. 2 into 3, 6. 3 into 0, 0. 3 into 1, 3. 3 into 2, 6. 3 into 3, 9. ఎగ్జామ్లో మాత్రం మీరు ఈ నంబర్స్ కావాలంటే పెన్సిల్తో వేసుకోండమ్మా. నాకు తెలిసి అక్కర్లేదు. మీరు 1 or 2 సమ్స్ చేసేసరికి యూ మే గెట్ హ్యాబిచుయేటెడ్ దిస్ ప్రాసెస్. Okay. Into what is x of n? 1 minus 1, 2, 3. Right? So now Twiddle factor finding and ఈ sum లో మనం పెద్దగా చేసేది మ్యాట్రిక్స్ మల్టిప్లికేషన్ ఒక్కటి వస్తే రిమైనింగ్ we can solve. సో ఇక్కడ ఫస్ట్ ఉన్న టోటల్ Twiddle ఫ్యాక్టర్స్ ని లిస్ట్ అవుట్ చేసుకోండి. ఒమేగా 4 పవర్ 0, ఒమేగా 4 పవర్ 1. ఇందులో ఉన్న Twiddle ఫ్యాక్టర్స్ చెప్పండి అమ్మా. ఒమేగా 4 పవర్ 2, omega 4 power 3, omega 4 power 4, omega 4 power 6, omega 4 power 9, right? ఇందులో మనం జస్ట్ n minus 1 వరకు చేస్తే సరిపోతుంది, అంటే 3 వరకు చేస్తే సరిపోతుందండి. రిమైనింగ్ ఆల్ వీ క్యాన్ యూస్ periodicity property. This omega 4 power 4 can be written as 4 plus 0, that is equal to omega 4 power 0. Omega 4 power 6 can be written as omega 4 power 4 plus 2, which is equal to omega 4 power 2. Omega 4 power 9 can be written as 8 plus 1, and 4 into 2 plus 1, which can be written as omega 4 power 1. Omega 4 power 0 is equal to e to the power of minus j 2 pi into 0 divided by 4, which is equal to 1. E to the power of minus j 2 pi into 1 divided by 4, which is equal to minus j. E to the power of minus j into 2 pi into 2 divided by 4, which is equal to minus 1. E to the power of minus j 2 pi into 3 divided by 4, which is equal to j 1 minus 1 minus j. So x of k is equal to 0, 0, 0, 0. Next omega 4 power 0, 0. Omega 4 power 1 minus j. I'm sorry, sorry. Omega 4 power 0 value is 1. So this is minus j and this is minus 1, this is plus j. ఈ కరెస్పాండింగ్ వాల్యూస్ ని ఇక్కడ ఆల్రెడీ మనం ఫైండ్ అవుట్ చేసాం కదా, ఆ వాల్యూస్ ని ఇక్కడ సబ్స్టిట్యూట్ చేస్తాం. ఒమేగా 4 power 2 is equal to minus 1, 1 minus 1 j. Here it is omega 4 power 6 which is equal to minus 1, and this is omega 4 power 9 which is equal to minus j into 1 minus 1 2 3. ఇక్కడ నుంచి ఇంకా మనకి జస్ట్ మ్యాట్రిక్స్ మల్టిప్లికేషన్ వస్తే సరిపోతుందండి. 1 into 1 1, 1 into minus 1 minus 1, 1 into 2 2 plus 3, 1 plus j minus 2 plus 3j, 1 plus 1 plus 2 minus 3, 1 minus j minus 2 minus 3j. 5 minus 1 plus 4j, 5 minus 3 sorry 5 4 minus 3 is equal to 1, and this is minus 1 minus 4j. See ఇక్కడ మీరు అబ్జర్వ్ చేస్తే సెకండ్ రో ఏదైతే ఉంటుందో సెకండ్ కాలం అదే ఉంటుంది, థర్డ్ రో ఏదైతే ఉంటుందో థర్డ్ కాలం అదే ఉంటుంది, ఫోర్త్ రో ఏదైతే ఉంటుందో ఫోర్త్ కాలం అదే ఉంటుంది. And finalized answer, if there exists a complex number, then its complex conjugate will also be in x of k, right? So this is how we find x of k. This is how we find x of k. Is it clear, everyone? Is it clear? Okay, fine, thank you. Then this is the end of this class. In the next class, we'll find inverse DFT, and I will try to give introduction to FFT. Okay, then you all can leave this class. This is the end of today's class.